Hi, everyone, and welcome to Trent University, to Zowski College, to Enwaying, and to Nosum Theatre. Before we begin, I want to respectfully acknowledge that all of these beautiful places are on the treaty and traditional territory of the Michisagig Anishinaabe. We offer our gratitude to the First Peoples for their care for and teachings about our earth and our relations. May we honor those teachings. My name is Michael Hickson. I'm chair of the Department of Philosophy at Trent University, and it's my honor to welcome all of you to the inaugural Groarke Debate. Established this past summer and offered by the Philosophy Department as a gift to the outgoing Trent University president, Dr. Leo Groarke, the Groarke Debate will be a biannual event that will bring to our campus two high-profile public intellectuals to debate an urgent topic of wide interest to the university and broader communities. And we could think of no better debate topic to kick off this series than artificial intelligence, friend or foe. Before we get to the debate, however, I want to acknowledge that this event would not be possible without the support and generous philanthropy of many people. I would like to acknowledge in particular the support of the current president of Trent University, Dr. Kathy Bruce, the Dean of Humanities and Social Sciences, Dr. Mark Skinner, the Kenneth Mark Drain Chair in Ethics, Dr. Catherine Norlock, the University Librarian and Head of Provost Artificial Intelligence Working Group at Trent, Emily Tufts, and to the work of Taylor Stark, Joanne Sokolowski, Elizabeth Bauer-Gordon, Dawn White, Jewel Bree, and Tricia Pierce. And I hope I haven't forgotten anybody. It took a large team to bring this together. This event is funded by the Leo, Louis, and Paul Groarke Philosophy Endowment that was established over a decade ago and was supported by the philanthropy of dozens of generous donors. I want to thank everybody for being here today. I see a wide variety of people. Thank you to the Chancellor of Trent University, Stephen Stone and Linda Schuyler for being here today. Thank you to Provost Michael Kahn for being here. Thank you to many others who have joined us. We have members of the community, high school teachers who are here, who are forming teams debate teams to come to Trent University in the winter to debate ethical issues. It's wonderful to see you here as well, and we look forward to seeing you on our campus again. Now to the debate. So as I said, we could think of no better topic to kick off the series than artificial intelligence. To some, AI is a revolutionary tool that promises to enhance human capabilities. But to others, it's a dangerous unknown, a Pandora's box, and maybe even an existential threat. And to others still, like this year's winner of the Nobel Prize in Physics, Professor Geoffrey Hinton of the University of Toronto, AI is both. It's an awe-inspiring tool and also potentially a threat to humanity. So there's much to debate here. And to help us think through these issues, we have invited to Trent University two of Canada's top AI specialists, Dr. Lai-Tze Fan and Dr. Makhan Virdi. So Dr. Lai-Tze Fan is the Canada Research Chair of Technology and Social Change and an Associate Professor of Sociology and Legal Studies and English Literature at the University of Waterloo. She's also an Associate Professor at the Center for Digital Narrative at the University of Bergen, Norway, and the founder and director of the U and AI Lab at the University of Waterloo, which uses research creation methods for enhanced EDI outcomes in AI design. Dr. Fan's work focuses on systemic inequities in technological design and labor, digital storytelling, research creation, critical making, and media theory and infrastructure. She's on the board of directors of the Trust Scholarly Network at the University of Waterloo, which examines public trust in scientific research impacting medical, technological, and other domains crucial to daily life. Dr. Fan's work in the Trust Network focuses on misinformation and trust in artificial intelligence in particular. Thank you for joining us tonight, Dr. Lai-Tze Fan. Dr. Makhan Virdi is a leading earth scientist and AI specialist with over a decade of experience at NASA, where he focused on earth and space sciences. Currently a lead research scientist at Science Systems and Applications Incorporated, Dr. Virdi spearheads the development of AI-based frameworks for scientific analysis. He plays a key role in capacity building through his contributions to curriculum development and mentorship in the Data Science and AI Lab, Software Carpentry, and NASA OpenScapes initiatives. Dr. Virdi also serves on the executive committee of the Trust Scholarly Network at Waterloo. Passionate about the intersection of emerging technologies and societal impacts, Dr. Virdi's research spans a broad range of applications of AI in fields such as earth science, climate extremes, hydrological forecasting, and atmospheric science. His prior role as science advisor at NASA's Atmospheric Science Data Center at the Langley Research Center involved providing scientific direction and enhancing collaboration among NASA's atmospheric science missions and the scientific community at large. Thank you for joining us, Makhan. Okay, so tonight's debate will be divided into 5 themes. We'll focus on the nature of AI and work, moral, legal, and political concerns with AI and the environment, and finally, AI and education. Each theme will be introduced by a question, and each debater will have an opportunity to respond to the question, as well as to make responses to the comments of the other debater. We've opted for a free exchange between the debaters rather than a rigid allotment of time to each of them, but I will be exercising my duty as moderator by keeping the debate on each theme within the time limits that we agreed upon for each of them. So if I interrupt you, it's not because I'm rude, I declare. It's because I want to ensure that we leave ample time at the end for a question and answer period with you, our audience. So on to the debate. Our first theme, what is artificial intelligence, will occupy us for about 10 minutes. So everybody here has undoubtedly encountered ChatGPT, and probably our minds turn to that when we think of AI today. But AI is much broader than ChatGPT, so we should begin the debate by clearing up some definitions. What is AI? What are some examples of it? Where is it being used today? And I'll start with Lai-Tze.
Okay, thank you so much, Dr. Hickson. Just checking that everyone can hear me. Great, thank you so much. So the question of what AI is a wonderful place to start, primarily because not everybody is on the same page with regard to what we mean by AI. And ChatGPT is a relatively recent phenomenon and technological product that we've been exposed to, which has really ramped up the conversation around AI and its possibilities, including both its benefits and its risks, which I think we will talk about today. What is AI? So the difference between the AI that we have now and the AI that has actually been around for multiple decades is the introduction of something called machine learning and also something called automation, which is not just to have a computational system that can complete tasks for us, which we've already had. Like if you think about Clippy from Microsoft Word back in the day, Clippy was a form of artificial intelligence in a way because Clippy was programmed to help you and answer your questions as an interactive interface in your word processor to guide you along in using a tool. But what's changed, and also maybe one way I can describe this is to say that the tools have become, we've trained them so that they can learn from us and then predict and anticipate what kinds of questions we are going to ask and what the best ways to answer those questions would be. And that's where the machine learning part comes in. I can talk about the training process a little bit more, but essentially one way I like to describe this, including, and that really I think starts to show some of the risks of AI in particular, is to compare the ways in which machine learning AI can learn language, for instance, just to follow along with the metaphor of, or the example of ChatGPT, how AI learn language compared to how we as humans learn language, specifically children. How do children learn language? And a lot of it is copy and response. So we are trained by our environments to learn how sentences work in a particular language. This is also how we learn new languages. You learn grammar, you learn vocabulary, and you populate according to formulas. That's absolutely what AI is doing as well. AI like ChatGPT. Those are specific AI that we call large language models because we give them trillions of words and say, learn the system, learn the patterns, and reproduce what I ask you, please. The difference, though, is that if you say to a child repeatedly, like, you cannot use this word or that word because it's bad, they will pick up on things like emotional nuance and with common sense and environmental and cultural contexts. This word is bad, that word is forbidden, you can't use this word at recess. So kids develop that ingrained way of filtering out and learning how to use language. But AI does not have that worked into its system. So it is basically a very sophisticated counting machine. It will just pick up on frequency. And frequency ends up becoming its foundation for probability. So there's a strong probability that these words will be used, even if they're bad, even if they're satirical, even if they're harmful. We will use them because they appear frequently. So one thing that is harmful there is not being able to intervene or to know when to not have those filters in there, and is leading us to a very different type of artificial intelligence, because if we don't account for those kinds of considerations and sensitivities, we're going to produce something that is built in our image, but doesn't necessarily have the same sorts of, let's say, morals that we have, the ethics that we have, and that we would practice in everyday life. I think I can sort of stop it there because I'm sure there's more to say, but just wanted to start with an overview and an example.
Okay, thank you. Makhan, what is AI?
Well, thank you for having us and to talk about the profound technology that we have discovered or invented. For almost 70,000 years, we have been perfecting language, which is probably the most sophisticated tool that humans have invented. And then we wrote stories around that. We did research. We created more tools using that. We gathered as a society. That's the most important and most sophisticated tools I think we have discovered as humans. Then come along this technology that mastered everything that we have done or created over the last 70,000 years. And it's better at articulation, the ideas, weaving stories, writing poems that can move you to tears. I think that is at the core of why we are having this debate, why we are thinking of AI as a friend or a foe. Why do we have all this fear? There's a unfair anthropomorphizing of the technology that we have. It doesn't have a conscience. To me, AI is a machine that can learn to perform or have a semblance of human-like cognitive abilities without the conscious. But we are very prone to conflate the two ideas and think that this machine that is going to help us with language, with analysis of data in medicine, in environmental science, and stock markets, it has got some agency because it's doing and pretending to do the work of its own volition. It's not. So to me, AI is training a machine to think like humans, to do analysis, to find patterns, which humans are very good at, but we can't scale it. We get tired, we make mistakes. AI is just another tool to me. That's on one end of the spectrum. And on the other end of the spectrum, it is a tool that has learned how to be creative, or at least give you a semblance of creativity. And when you look at the images that are generated from artificial intelligence, it's very difficult to discern whether it was created by a human or by artificial intelligence. I work in this field. I design systems from scratch that are based on artificial intelligence technology. I took a test. The system showed me 100 images, and I was able to identify 71 images out of that correctly. And I was wrong like more than 30% of the time that whether that image was generated by AI or human. So we are at this like cusp of going over to the point where we created this tool that has the capabilities that might not match the best in their field right now as of today, but it's better than 99% of the people who work in that domain. So there are only 1%, and those people are probably designing these systems. It's only a matter of time when this technology surpasses humans. So AI does not have motivation to do things that it does. Humans behind AI, they have motivation, and now that can be positive or negative. Right? I want to draw the attention to like two Nobel Prizes that were announced like this week. Physics, very human-centric field. Chemistry, very human-centric scientific field. Physics was awarded to Dr. Jeffrey Hinton, who created the systems that Lai-Tze already talked to about. Like it's designing a system. You give it a lot of data, X and the Y. This is the input. This should be the output. It looks at input, looks at output, then creates an internal structure that tells the model or wherever it is used, that if this is the unseen input, this is how you are supposed to look at the output, and this is what the output should look like. So now Geoffrey Hinton designed the algorithm that looks at those two inputs and outputs and finds the difference of how much of the model generated output is departing from the ground truth, and then it back propagates that to the beginning, and then it does that millions of time on millions of the data sets X and Y, right? Another chemistry was awarded to Demis from England for his work on proteins. So there are over 200 million proteins known to humans. Deciphering the structure, the 3D structure of folding of that protein takes one PhD, 4 to 5 years at least. So we have 200 millions of those. And the system that he created was able to decipher the 3D structure and the implications of those molecules in 1 year. So that's 200 million times like 4 to 5 years of PhD. That's like 1 billion years of PhD in 1 year. So that's the kind of profound insights that we're looking at that AI can generate as a tool. So to me, AI is a tool minus the consciousness. It will do whatever we ask it to do. So the onus is on us as a society, as developers of these technologies, creators and consumers both, policymakers, to make sure that we use it wisely, we develop it wisely.
Okay, wonderful. Thank you. So we've heard about AI as a tool. We'll come back to that in our second theme on AI and work. We've heard about the morality of AI. We'll come back to that. I do hope we'll have a chance to come back to AI and creativity. I just want to let you know on my phone, my wallpaper is the best picture I have of my dog. And it was created by AI on the basis of 3 sentences of description of my dog. So it is awfully creative. Okay, so moving on to the second theme, AI and work. We have a better sense of what AI is, and we're all in agreement about that. So our debate is quite friendly so far. So let's turn to ways in which AI might be friendly to us or a threat to us in the workplace. And I'll start with Makhan. What good is AI doing today in terms of expertise, work, and labor?
Well, to me, AI, I think, is a game changer when it comes to boosting productivity at work. So let's first talk about that. So it does a lot of what we do as humans in a more efficient fashion. It doesn't get tired, doesn't get hungry, doesn't get angry. It doesn't lose its perspective or the objectivity. And at the same time, it increases the productivity of the human. So it's not human versus AI so much to speak. It's more of using it as an ally to enhance what you're doing, increase productivity. And one of the things that I often wonder about is what will we do with all the time and the less cognitive load that we will have if we delegate lots of mundane and repetitive tasks to AI. Now, we can spend all that time scrolling cat videos and without guilt when AI is working for you. But I think that it's much more than that. I think after the Industrial Revolution, we have been getting busier and busier and busier with the more repetitive, more mundane, more paperwork for professors and everyone in academia. So we have lost track of what it means to be human and where we can make a mark in terms of the original thinking, critical thinking, developing something new and raw, and that just comes from within you as a human, that we did back in the time of Greek philosophers, and when the only field of enterprise was philosophy. Then somehow it diverged into like two. Philosophy and humanities became one, and technology and engineering and science and industry and everything became another one. And somehow humanities took a backseat in this pursuit of advancement of human civilization with the tools and the technology and the work and the factories and everything that we have created. I think now is the time. This technology will probably bring these two fields back together, because when we have a tool that has the semblance of human capabilities that can work tirelessly to do the stuff that you were so good at doing or got lost doing, and you thought like that is the main goal of human life, to spend countless brain cycles, or sometimes it's not even brain cycle. I think 90% of the work is blue collar job. And now there's a line that AI has crossed from blue collar to white collar. It's also coming after the white collar jobs. So, so one of the fields that is being really impacted, or in a positive sense, is education. We can create tools that can act as, I'll keep on saying tools because I don't want to, I want to diminish the impact that AI technology is already having by bestowing, that we as a society are bestowing a human-like anthropomorphic character on that. So a tool or a teacher or an assistant that is helping students learn in a certain way, because not everyone have a same learning style. So imagine a teacher that has got millions and millions of hours of experience teaching kids who are neurodiverse. And this is a tool, this is a teacher that doesn't get tired, doesn't get angry, have a lot of patience, and can tailor its teaching methodology based on your progress. So I think education is one. And the other one that I have is the healthcare and business. We talked about the Nobel Prize in Chemistry. Discovery or estimation or prediction of the properties of a chain of molecules is having profound impact on drug discovery and tailoring the drugs, and specifically pharmaceutical industry, to specific needs based on their specific humans' genetics. It would have taken us 1 billion years to decipher all. Let's say if there was a traditional advancement, maybe like 500 million years to decipher all those 200 million proteins. Now we have that, and DeepMind, the company behind that, open sourced all of those 200 million structures of those proteins. So that is profound, and it's available for free to everyone. So healthcare is going to be, the drug discovery is going to be accelerated by this one. So job opportunities, people often talk about like job displacement, everything, but I think it's going to create new kind of jobs. When steam engine converted to internal combustion engine, horse and buggy people, they did revolt, or at least protest the coming of these cars that are run by this magical internal combustion engine. And then slowly we adapted, and people who were making whips for the horses, they went on a strike as well. So I think those are very human centering issues, and they will always be there whenever they are a technology that's as disruptive as artificial intelligence comes around.
Okay, thanks. So I'm hearing some optimism on this side, that it's a tool, it's going to give us maybe free time, allow us to be, Aristotelian contemplators maybe with the free time that we have. It could lead to advances in medicine. Lai-Tze, where do you stand on this? What's the impact that AI will have or is having in work?
In work and in other forms of thinking about work, essential work, labor, I think some of the structuring that Makhan has responded to is, I probably have the same structuring, just the ways in which I'll look at it might be a little bit different. So with regard to, for instance, some of the challenges, even in the way you described AI, I should look at everyone. Even in the ways of the capabilities of AI to tackle specifically the issue of scale and size, huge amounts of data, that's unprecedented for us. But also what we do with all that data is also unprecedented. So it is true that we will not, as individual humans, even as collective humanity, be able to do all of that work at the same, not just scale, but also speed. At the same time, I think banking on AI to solve our issues of speed and scale alone becomes dangerous quickly, because this is also I guess in relation to the first question, what is AI? Also, how is it made? And who is making it? And who is making these decisions about what kinds of jobs AI will replace? What kinds of labor needs to be replaced? Some of that can be extremely important research-based work, including in pharmaceuticals, including in medicine, and I'm also interested in medical AI. However, I think we are very interestingly seeing a disparity in the types of AI and what they're being asked to do. So a lot of what my work in AI deals with is issues of EDI, equity, diversity, and inclusion, and that might include, for instance, the labor that AI are asked to do that reminds me of social stratifications, the ways in which those can be reinforced. So Makhan had mentioned, for instance, the replacement of blue collar jobs with AI, and then now the moving towards replacing white collar jobs. So it's not just going to be self-checkout counters and robot servers and robot nurses. Those are all valuable jobs, and they're forms of essential work. It's also now thinking about software engineers are actually finally, or for once asking, well, what's my future going to be like if I'm going to be replaced with a ChatGPT or GPT-4, which can program better than me and much more cheaply. So I think that there's a question mark on this labor, the topic of labor and work overall in society, but it also reveals a lot of values to me about what we deem significant. I don't think there was a lot of batting of eyes when self-checkout counters started to emerge, particularly during the pandemic. You could just get in and out with your groceries and not have to engage with anyone, and they didn't have to touch your things. However, increasingly, I think that the types of AI that we're asking to, let's say, work in retirement homes and hospitals and restaurants, all of that work is actually already in society, invisible work. And what I often refer to with my students as work that we delegate and often pay less because it's by some sort of conception below our pay grade. So that's where we delegated a lot of AI labor first, and where we're programming a lot of the work. It seems interesting and not at all an accident to me that the concern now about white collar jobs being replaced by AI is to do with the fact that it's like, oh, well, suddenly it's a group that we care about. So it reveals a lot about our values, and I think AI is a really good mirror for that, including what our fears are in regards to it. So a lot of my work will be about, let's say, AI assistants, which are, they're called assistants, and they're modeled after forms of gendered labor a lot of the time, domestic labor, secretarial work, and so on and so forth. So I think we have to be very careful about where that work gets allocated and how we reinforce some of those models of work. Just using the example of AI assistants, most of the ones, especially in North America, are programmed to have female presenting voices. And that's because you're imagining your assistant or the person who's like making your coffee is female presenting. And just as an example of like how far that goes in terms of social stratification, the voice for Siri, Apple's Siri in the UK, is male and sounds like a butler. That reveals a lot about values. So I think that what you're saying, especially in terms of size and scale, is correct, but who's making those decisions, and in what kinds of ways are they reinforcing ideas of work that maybe we actually want to do away with? And now that it's automated and there's no one to complain, is there going to be like an AI union? What's going on?
Okay. That leads us into the third theme, some moral, legal, political, and union concerns with AI. So while many people are impressed by the work that AI can do, many others are concerned about the moral, legal, and political dimensions and implications of that work. So I'll turn back to Lai-Tze to start this discussion. What moral, legal, and political concerns do you have about the growing presence of AI in our lives, and how serious are those concerns?
Quite serious, primarily to do with the fact that it is in a way up to us to shape the futures that AI are predicting for us. But the us here does not necessarily include me and you. It's people who have the technical know-how. I am in full agreement with Makhan's suggestion that state policymakers should be involved, academics should be involved. Not just creators, but also consumers, they should be involved. They're not always involved unless there's whistleblowing involved or a stone gets unturned, and then we start to realize some of the more potential conflicts. The media scholar who has quite an interdisciplinary background, Wendy Huikyung Chun, often describes AI in this way. the future equals the past. And what she's referring to is the training process of AI. So you take a trillion data points and you give them to a machine and you say, learn and figure out what the patterns are. And then now that you know everything, you can answer the questions better than any human. But often a lot of people will think about this in terms of algorithmic fairness. Well, how are you teaching it? And what are you saying should be important? That's important, of course it is. And in conversations that I've had with politicians and policymakers, they'll ask me a lot about algorithmic fairness, like what are the ideals and the ways that we're training? And then I'll say, that's only about that's only part of the story. The other thing we have to think about is what we're training it with, which is data. I already mentioned data, but there are many, many different ways in which data can be extremely biased. And this goes back to to Professor Chen's comment, the future equals the past. You take this data that might be from yesterday, or it might be decades old and no longer represent our values. And that's what's fed into a system that now is supposed to predict the future. So you're taking potentially information that is anachronistic. So against time, it's out of date, and we use it to feed into the future. Why would we do that? A really good example of that is some of my work is in facial recognition, and it's used in the technology is used in things like border control, security, predictive policing. And a lot of facial recognition technologies are trained in data sets that they need millions and millions of faces, ideally, and sometimes billions. But a very, very popular training data set is the US domestic mugshot data set, because it's free and it has millions of faces. But if you imagine what kind of faces might populate that data set, it's no accident, for instance, that a lot of Western facial recognition technologies are extremely biased and wrong when it comes to indigenous faces and also Asian American faces, a lot of faces of color. A lot of Black women in particular have been wrongfully arrested based on the suggestions of facial recognition technologies. So there are political issues here that have to do with the lack of, consideration when it comes to curated data. Why would anyone choose a data set that's clearly biased? However, I will mention, and maybe this is actually for more of a back and forth, but any attempts, this is my most recent project that I've been thinking about, any attempts to correct the lack of racial diversity in these types of technologies with more data is also not an answer. So that's sometimes something that's been referred to as technological solutionism. There's a problem with this technology. I will make another technology to fix this problem. The equivalent of that would be like your doctor saying, well, your knee hurts, I'm going to give you this pill, and your knee will stop hurting, but now your elbow hurts. So with what's been happening is that companies like the US company Clearview AI scraped billions of images of people off of social media without their consent, and therefore came up with all the faces that they needed. A lot of them were being trained on data sets of people with mostly light-skinned features, and faces. And the solution to that was to get more data. The problem is that data was not collected with consent. So in 2021, the Privacy Commissioner of Canada banned Clearview AI. So that's good. But the US did not ban it. And also it begs the question, like you solved the racial question, but you didn't do so ethically. So how do we reconcile something like that, like two different goals towards fixing a problem and using a technology? How do we use data and that it's not exclusionary, anachronistic, potentially biased, a combination of these things? I don't know if that's specifically for you or if it's just a rhetorical question.
Well, why don't we turn to Makhan and see?
Sure, yeah. I think we have to be very careful when we talk about the dangers of AI, so to speak, with what is real and what's not real. I'll explain that further by saying lots of the problems and the dangers that we talk about and the faults, it's us. Most of those are very, very human-centric. I think it's unfair to blame a technology or a tool for human shortcomings. And since like she mentioned that it's the past that's being used to train And we are using that trained model to predict the future or suggest what to do. So it's difficult for something that has happened in the past to predict what is the best course of action for the future. So, and all the biases, whether that's in facial recognition data or in the literature that we have written over the past 200, 400 years that is being used to train, or all the news articles or the traditional gender societal roles that we have. If we use that data to train these algorithms, then obviously it is a reflection of what we have done as humans in the past. So it's, I think, unfair to blame the technology, and it's a cop-out to push the responsibility away from us, that's what we have done in the past. We are still struggling with defining and finding the right objective human values, morals, ethics. I want to draw your attention to two more Nobel Prizes that were announced this week. One is literature, a South Korean author who wrote on the plight of humans, the history, and what we have done in the past in a very metaphorical way. The other one is Nobel Prize in Peace. The person who received that Nobel Prize is in jail in Iran right now. So we are for fighting for human rights, women's rights in particular. So we are still trying to figure out, like, and these are the 4 Nobel Prizes. Everything else is also somehow related to the plight of humankind, or to make it better, or to highlight what's not right. So we are still struggling to find what's the right balance between what we can do, what we cannot do, what's the right human values, the values that were right like 40 years ago are frowned upon right now, and maybe what we have right now will be frowned upon in the future. So while we develop these technologies, we have to be mindful of what it means to be human, what is right, what is wrong, and then be very, very careful when we are designing these technologies. And also, it should not be the domain of engineering and technology alone. I think this is a time when we have to converge these two branches of enlightenment, I would say, or inquiry that departed couple hundred years ago. And we have to bring these two things together and make sure that we are doing everything in interdisciplinary fashion. There's this departmental lines, demarcations at a university level or even in the societal level have to go away. We have to think about the underrepresented people and what aligns with them. We have to bring all stakeholders, be it government, people from the environment side, citizens, scientists, skepticals, climate change deniers, vaccine anti-vaxxers. We need to have a very human conversation about what is the right thing. And we can't vote on these things. Everyone have to agree, because it only takes one bad actor to use a technology as powerful as this to make things go bad. But we have to separate what are the human issues and what are the technological issues. And a lot of these issues can actually be solved by technology. You can have AI systems. I think Jeffrey Hinton suggested the other day, like 2 days before, I think he was interviewing with CBC after winning the Nobel Prize, that we can have AI systems that monitor AI systems. That's a bit like saying like police doing audit on the police. So there are some challenges, but I think the solution lies in the interdisciplinary discussions and work.
Would you like to respond to that?
Sure, I can do so a little bit quickly. I actually think the idea of interdisciplinary work is going to be part of that future, particularly not just within academies and with researchers, and whether they're in academic or industry spaces, but also to go multi-sector. So talking to designers specifically, having conversations across sectors like you and I are doing, also speaking with policymakers and making sure that people are on the same page. Some of my time that I've spent as, I guess, an observer and sometimes consultant at Parliament Hill, I'm struck by the ways in which policymakers and I are we want the same things, but we're using very different language. So language seems to be an issue in terms of consensus and moving in the same direction. So they'll ask for action items, and I'll say, well, I can't give absolutes when it comes to research that's still ongoing, but here are some suggestions. So it seems like understanding what they're looking for, especially since they're the ones who are going to enact change, is a big part of that. And I'm not going to know that by publishing papers that like 10 people and my mom are going to read. So sorry, that's no offense to anyone's, especially anyone who does traditional research. It's more so having those conversations has been so valuable for me, precisely because it allows me to think about what this looks like on the ground, not just for civilians and not just for my students, but also for working with designers and developers, working with policymakers, and working towards things that look a little bit more robust in legal frameworks, because currently Canada does not have one. This is just a piece of information. Bill C-27, the Digital Implementation Act, is still on the table at the House of Commons. It was proposed in 2022, I think, I forget which month, but it was put back on the table in May for the summer adjournment, and they've picked it back up. And so far there has been, at least in public facing, from my public facing understanding, no development on it. But that's the act that will make some suggestions, for instance, on how to regulate AI in a Canadian framework. I think one thing that we can do, instead of just trying to all start from scratch and reinvent the wheel, is to also look at what other countries are doing, especially if we're going to have to agree with them anyway at a certain point, because AI is not national, it's not even international, it's planetary. I'll get into this when we talk about the environment, but we're dealing with a lot on multiple scales. You know what? I'm going to stop it there.
I have a quick comment on
Yeah,
that one. So,
please.
So we do need international cooperation on making these regulations, and everyone adhere to that. But the problem with that is one size will not fit all.
Yeah.
Because all the different communities and geographically, socioeconomically diverse communities across the globe, they are going to be impacted by this technology disproportionately. So we cannot have one solution and regulations and then say, okay, this is what you are supposed to do. There are certain countries, communities that still need blue collar jobs. There are more people. They can afford more people to work on manufacturing, so to speak. And if we have regulations that are based on for lack of a better word, Western mindset, then we'll have to make sure that it does not. Even at United Nations level or at the international forum, that is happening with the climate change. The IPCC, International Panel on Climate Change. You cannot have 3 or 4 voices dictating what the rest of the world should be doing, because it's disproportional. It's not aligned properly with the local communities. So I think that is the challenge, where we have to make sure that we have one body or set of regulations to sort of dictate what goes on in an overall umbrella, overarching fashion, and then also have enough decentralization that we have organizations, the creators and the consumers of this technology working together at a local level and making those rules and regulations. And the other thing that I want to focus on is the transparency of the algorithms, of the data being used. For example, pharmaceutical industry is a good example. We can learn from that. You are not allowed to create concoctions in your garage and sell it to people. You need to go through an approval process, and you have to be transparent about it. You have to have multiple studies, clinical trials and all the things that precede that. And then once you put it out there, then you have to have a label that tells you what's in there. Except for homeopathy, which is a different story. You can put any label on that one. It doesn't matter. It's water. So you have to be transparent. There have to be regulations that you're not just creating stuff and then selling it. But the challenge with this technology is any person with a computer sitting in a cafeteria using VPN or the free Wi-Fi can wreak havoc by using these technologies. And I also want to draw like slight difference that I think I should have talked in my very first opening statement, that AI is a very vast field. It's not like the stuff that suggests you cat videos and write your term paper and stuff. It's much more than that. AI is a very, very, very old field. Why it's picking up right now is because of the readily available compute resources that we didn't have back in the days when this field was envisioned in the 50s and the 60s. Even before the computers, the mathematics, it's numbers doing number things. Billions and billions of nodes being trained by billions and billions of data sets on what is input, what is output, what's the difference, reduce that difference, and now we have a model. And neural networks is what I think we are focusing on right now in the deep networks. Deep networks is like you have like millions of nodes that are being trained by these supercomputers. Now, the silver lining here is I think it has got both aspects. On one side, it's the power to create these tools and technology is in the hands of a few big corporations, because they can afford to have like large supercomputers and scrape all the data that you have like posted on Facebook, Twitter, whatever, and from across the web, which also makes it easier to regulate, because there are only few points of or few sources of dispensing these models. That makes it like slightly easier to have regulations. Now, on the flip side, it's also a danger because it's concentrated in the hands of a few organizations, and even within that organizations, we have fewer individuals who dictate the whole thing. You must have heard about what happened at OpenAI. So Jeffrey Hinton, the professor who won the Nobel Prize, his student Ilya, he was the chief science advisor at OpenAI, and there was a disagreement on where the artificial intelligence should go. So we are talking about artificial general intelligence that will have capabilities just like human, and it's not like narrow AI, which is one specific task. So we are going from like narrow AI, which is like, an example is self-driving cars. We're going from the narrow AI where it's trained for one single purpose to general purpose artificial general intelligence. But the silver lining again is that we have people who are in this tech world who are creating these technologies, who have that sense of what to create, when to create, and along with how to create it. So I have not lost hope that I think we will have AI co-workers. I think there is still a bit of time where we will have AI bosses.
Okay. All right. Thank you. We'll end that theme on that point. So we'll move on to the theme of AI and the environment. So most of us, when we use AI apps like ChatGPT, don't think about the fact that there is an enormous energy consumption behind the training and the use of AI. So this raises questions about the relationship between AI and the environment. And I would like to turn to Makhan again. Given your decade-long experience working for NASA, can you share some of your experience with how AI might be used to combat climate change and promote sustainability without introducing new environmental risks?
Well, thank you. That's a very important topic I think we should address. And working with NASA in environmental sciences and earth sciences, this is a field that's very close to my heart. And first few years of my career, I worked with traditional tools, statistics, and then artificial intelligence came around, which coincided with more and more satellites being launched. We have NASA alone has more than 24 earth science satellites that go around the globe collecting data. And every year, every new mission, every new satellite that is launched will generate multiple times more data than all the previous satellites combined. So it's humanly not possible to sift through all that data and make sense out of it. And because the data is higher resolution, both in temporal and in spatial domain. So we have sub-kilometer resolution data for the whole globe and being collected from hourly to daily timeline. So that's lots and lots of data. So it's not possible for a human to sit and use traditional algorithms to sift through that data. And also the other thing is, like, if we train enough artificial intelligence machine learning algorithms, we can move it to the edge computing, which is the satellites or the devices that are collecting data have the intelligence to not just keep on collecting mundane data, but to look for the events that we are interested in the first place. So we don't have to collect all that data. We don't have to store all that data. And that also comes, it brings me to the point of sustainable AI, because AI has a huge carbon footprint. To train one simple large language model, the basic large language model, it takes the lifetime emission of 2 to 5 sedans. And when you interact with ChatGPT or any other model for like 10 or 15 minutes, the amount of water consumed is ½ liter to 1 liter. So how do we mitigate? These are the actual impacts of environmental impacts. But before we go there, like how to mitigate that and what are the real challenges there, let me finish the thought on like what AI can do for you in earth sciences. So one important field is agriculture. The land that is used to grow food for people is reducing. I'm from the Waterloo region. I spend a lot of time there. It's called the Green Belt. And in the last 5 years, I've seen maybe more than 100 developments, all of them happening on the land that is supposed to produce food for the growing population. So on one hand, the population is growing. We will be crossing 9 billion, and 9 billion people on this planet is sort of the capacity. So think about it as like a 3-bedroom apartment. You can fit maybe 6 people. If people sleep in the living room, maybe like 10 people. But eventually the kitchen is gonna get dirty, the bathrooms are gonna get dirty, and there won't be enough air conditioning for people. And then we will not know who made a mess in the living room and the dining room, and who didn't clean after themselves. So we are on the spaceship Earth, and the population is growing. Food, energy, and water requirements are growing. At the same time, it's taking a toll on the resources that actually provide those three: water, energy, and food, that the critical nexus. So we do need tools like AI to create processes that are efficient, create buildings that are energy efficient, and suggest ways to produce more food. For example, I worked on a project when I was at Oak Ridge National Lab a couple of years ago, working with Bill and Melinda Gates Foundation to create tools that will look at the crop cycles, the growth cycles from the space, from satellite imagery. It was focused on the Southeast Asian countries, Bangladesh, India, Nepal, to predict where we can introduce better irrigation methodologies to increase the crop yield, just by looking at the satellite imagery and then following the track of how the plants are growing. When is the harvest season? When is the growing season? What's the right growing season? What's the right harvest season? Is there any infestation that's going to occur, and tell it before time? So there's a lot of opportunity there to in the food sector, in the energy sector, creating more renewable resources, using more renewable energy. So now coming back to the impact of all these technology. So we do need this technology to create food security, energy security, and provide water to everyone that's on the planet. But using this technology and creating this technology, it does have its own impact. And since, again, like I'll go back to the point of, like, since it's only a few organizations that are doing it, it's much more easier to transition them to more alternate green ways of doing things. Data centers consume lots of energy and water. So since there are only a few organizations who are like using lots of resources, you can name them on your fingers. It's easier for us to ask for regulations that require these data centers to be green. They have the money and the resources to do that. The only thing that is required is a little push and willingness and cooperation.
Okay. So I'm hearing friend and foe with respect to the environment. Do you side with one or the other, Lai-Tze?
I think in terms of the advantages for multiple forms of research, including environmental research, agricultural research, and the ways in which those can be enhanced, it's true that AI can help us deal with forms of research activity and also improvement and societal improvement. I think, though, the problem that I'm seeing here is that it's whether the benefits outweigh the potential risks in terms of what else is done in the meantime. So can we use AI, for instance, to catch up to and fix the damage that AI also might cause? That's the way I would try to frame that as a question. And just to use you use the example of training a large language model. The energy consumed is the lifetime emissions of 2 or 3 sedan cars. I'm thinking also training Google's BERT, which is one of ChatGPT's antecedents. It's a few years older. That took the amount of energy that it would take to fly a transatlantic flight. But that's a huge amount of energy, but the sedan statistic is actually more, which means that we're also consuming more energy now with the AI today than a few years ago, which means that in another few years, it will be even more. And while I'm all for using sophisticated tools and technologies to fix some of our existing problems, especially, again, relating to size and scale, I'm also perplexed about how to catch up with the other forms of damage, including like that research is going to be helpful for everyone, but also the environmental impact affects everyone. So why is the land not great shape? Is it because of forest fires or drought? And is that being caused by the fact that we're deforestation is happening greater than before, and also we're mining more? A lot of that is actually to do with the technological industry, and this isn't just specifically on AI. I've worked a lot on issues of e-waste in the past and the environmental impact of e-waste. The resources that we have will come from Earth. I mentioned briefly earlier that these issues are not just on a global scale. They're not just my problems and your problems. Sometimes I call them global because my phone here will, for instance, the lithium-ion battery in all of our smartphones contains the mineral coltan, which has to be mined in places like the Republic of Congo. The glass might have come from a factory that's perhaps built in Kentucky or Tennessee. It's designed in California. It's assembled in China. Maybe the battery was created in South Korea. We have a global product, and it gets shipped to us in Canada when we purchase and use it here. But also things like gold. I was a full adult before I realized and found out that gold comes from outer space. So now it's all of a sudden it's a planetary issue. We don't have resources on this Earth. We're going to have to go and look for them, which is also something NASA does. But I'm mentioning this because we are running out of the resources to be able to keep up. And at some point, we're just going to completely run out. So actually looking for greener and more sustainable methods is going to be the only way. We're going to have to find more renewable forms of energy in order to ever catch up. And if we can't, then I think that's worth a very, very serious global conversation.
We could continue, but we're short on time. So if you don't mind, maybe we could continue that in the Q&A period, because we want to get to AI and education since we're at a university. And my sense, as a department chair with my colleagues, as a member of the AI working group at Trent, and as an instructor where I have students conscientiously objecting to my AI assignment in my class, hi Star, we're divided here over whether AI has a place in the university or not, whether it's going to improve education or not. And so I really want to get your take on that. So I'll begin with Lai-Tze.
Okay, I can talk about education and AI and forms of AI in the university setting, but also I've been increasingly interested in how it plays a role in classrooms for students K to 12. I think that there's a bit of a responsibility there as well, especially because we can't expect them to come in and already know what our rules and regulations will be institutionally. So I'm this might surprise some people, I'm okay with using AI in the classroom critically. So there's nothing wrong. Actually, to use your term of AI as a tool, AI is a tool. Sometimes it gets compared to a calculator. I'll talk about math all of a sudden for two different reasons. One, we can all use a calculator and it's extremely helpful, but I'm not a mathematician, but if I were to train to be, a calculator is not going to help me. I need to understand the math before I can use the tool in order to understand its affordances and limitations. At the same time, I'm using math because I was a terrible math student growing up, and this is pre-university because I didn't major in math. And it would have actually been really great to have something like AI that is personalized to my experience. As someone who's a visual learner, I often felt like I couldn't keep up in class with a teacher in high school or elementary school explaining, this is the quadratic equation and et cetera, et cetera. I would have preferred a form of education in which I could ask questions and would not. I don't know if anyone has had a student raise their hand and said, this is going to be a stupid question. They still ask the question. Some people will not ask. And I think that we're not accounting for accessible forms of learning if we're dealing with huge, huge scales of students. So in some ways, AI can be personalized. I actually spoke to your student who didn't want to do the AI student assignment. Hi. And I suggested ways in which AI can be a personalized form of education. Does that mean it should replace teachers? No, but it can be a really good personalized mentoring tool as long as you understand the math behind it. And this is where I bring in, just quickly, I know we're running out of time, but like the word critical, using these tools critically is important to me. Earlier this year, and actually from a project starting last year, I worked with 250 7th and 8th graders in the Kitchener-Waterloo region to teach them how to use generative AI critically. Because they were going to use it anyway, and they were going to see it with their, older siblings and cousins and see it on the internet, and they were going to become exposed to it, including what it can and cannot do. And it was better for that conversation to happen where they can ask questions and also understand, like, that's not real and that's not real. Don't fall for that. That's important from, 7th grade and even earlier. So I taught them how to use generative AI art tools, specifically, if we want to merge education and creativity, perhaps. And one thing we would do is write out prompts for these models and say, like, well, just generate me a classroom full of kids, and then start a conversation. All the kids in this classroom, like, what's wrong with this picture? And then they would say, all the kids are white, or like they all look like the classroom looks like it doesn't have any books. But they point out things that would make them rethink, like, this doesn't represent me, and this doesn't represent what I think of as a classroom. So it's just a very simple example just to let them know and get on board with the fact that what they're asking for and what they're getting back in response might not even be what they want, and what might not match with what their realities are. So using that in a sort of safe and open conversation and environment allowed them to encounter AI in a way that is a little bit more critical. It's inevitable that they will encounter it. So I just want to make sure that they're doing so in a way that they're informed and not going to be misled.
Okay. Makhan, I've watched a lot of presidential debates, and sometimes they don't answer the question, but they go back to the old question. If you want to do that because you had something to say about the environment, you can do that, or you can talk about education. I'll give you your choice.
I don't want to sound like a politician who's telling you everything is going to be okay. And so no, she pointed out, like, the deforestation. I think that's an important issue. Deforestation and afforestation, or getting carbon credits, like all these big companies that put out a lot of carbon in the atmosphere. Like she talked about the transatlantic flight. For example, Air Canada can say, okay, we have bought these many metric tons of carbon credits, which basically means they have purchased land in the Amazon where they're reforesting that area, right? So now AI is an incredible tool for that kind of stuff to hold these corporations accountable, so that then they're not greenwashing by just buying some credit for the future, the carbon credits for the future. You can guilt-free put more carbon in the atmosphere, right? So there are tools that can actually monitor the growth of the forest and actually estimate the amount of carbon captured by looking at the satellite images and how big was the tree canopy cover over the years, and it will give you a good estimation of like, okay, how much of carbon credit actually is worth, and do a objective accounting and audit of all the carbon credits that they're talking about. So
Okay.
that's what I want to mention.
Okay. Did you want to add anything else about education before we turn to the question and answer period?
One quick,
Sure.
2 points. One on the educator side and one on the learner side. So learners, of course, let them have fun with the technology. Make it very, very acceptable in all the courses that, okay, it's totally okay to use it, but use it critically, like she said. What that will do is it will make sure that all the learners in your class very quickly get to a point that covers everything that we have known as humans in the past. And then you can get to the point, okay, now, this is what these points are. These are the different aspects of this specific thing that my professor asked me to do. Now, what next? Can you add something on top of that on the learner side? And then another is like you have to embrace the customizability of these virtual instructors. Just taught millions of kids. It knows where if someone is stuck at quadratic equation, how to break down the problem into like smaller steps and make education more accessible to anyone with any kind of needs, neurodiverse needs, and also like across the geographical boundaries. Now imagine like you have the combined knowledge of all the professors from all Ivy League, all the top universities at your fingertips at any corner of the world. That's empowering. And on the educator side, you can use it to like a research assistant or a teaching assistant to bring the best points from all over the world and make the next best point that has not been covered by anything that has been taught in the past centuries. So it brings about this capability, like it enables you to think more critically and go one up what has been done in the past. So really, I think if N is the combined knowledge of all these models of this AI, N+1 is where humans will outshine this. And that's, I think, should be the endeavor. We have been lazy for the past so many centuries, just repeating the same thing, getting stuck in the mundane jobs and doing mundane tasks repetitively. We think we have changed the definition of what is being creative. How are you adding value as a human to the society and the future? Is it like just repeating the same thing that has been done over the past so many years? Just because we have created so much of knowledge, it's not humanly possible to wrap your head around what has been done. So you don't even have time to go beyond that. So take any point, use the tools, quickly arrive to the point where you are either out of ideas to contribute or have something new to contribute to the past.
I think that's a nice note to end on for the formal portion of our debate.